In this particular example, we will take a look at joint BE in a larger truss system. As we saw from the previous example, we solved for the reaction force at B in the y direction and got a value of 525 pounds. We also have beams BE and BC acting at joint B. Beams BE and BC are drawn with the arrows pointing towards the joint to represent those beams being under compression. If the arrows were drawn in the opposite direction, with the arrows pointing away from joint B, then they would be said to be drawn under tension. In order to solve for the missing forces, we can use our equations for static equilibrium. And those are the sum of the forces in the y direction is equal to 0, and the sum of the forces in the x direction is equal to 0. If we take a look at our two equations, we see that all the forces must be acting in either the x or the y direction. However, BE is currently neither in the x nor the y direction, so we must first solve for its force components, as is shown in the diagram in the upper right-hand corner of the screen. In order to get BEY and BEX, we must use our trig identities. We see that the angle theta is marked in the diagram and represents an angle of 63.44 degrees. BEY is on the opposite side from the angle, and therefore we will use the sine function in order to solve for BEY. So we get an equation that BEY is equal to BE sine of 63.44 degrees. And since BEX is adjacent to the angle, we get that BEX is equal to BE cosine of 63.44 degrees. Now that we have the x and the y component of BE, we can use our two equations for static equilibrium to solve for the missing forces. First, we will analyze the y direction. So we will take the sum of the forces in the y direction is equal to 0. And our two forces in the y direction are negative BEY, since BE is acting in the downward direction, and RBY, which is positive 525. Now, we are looking for BE and not BEY, so we need to make a quick substitution. Since we know that BEY is equal to BE sine 63.44, we will substitute that into our equation. So we get 0 is equal to negative BE sine 63.44 plus 525. So now we will rearrange the equation to start getting BE by itself. So we will add BE sine 63.44 to both sides to get BE sine 63.44 is equal to 525. The last step to get BE by itself is to divide both sides by sine of 63.44. So we get that BE is equal to 525 divided by sine of 63.44 degrees, which equals a value of 586.94 pounds. Next, we will analyze the forces in the x direction, which are going to be equal to 0. We have two forces that are acting in the x direction, and these are BE in the x direction, so the x component of BE, which is to the right, so it will receive a positive sign, and BC, which is also facing to the right, so it will receive a positive sign as well. In the previous example, we solved for BE and not BEX, so we must make a substitution in order to plug in BE. So we get 0 is equal to BE cosine 63.44 degrees plus BC. Earlier, we solved for BE and got a value of 586.94. Now, what we must do is solve for BC. So, we will bring 586.94 times cosine of 63.44 to the other side. So we get a value of negative 586.94 cosine 63.44 is equal to BC. Finally, as we simplify the left side of the equation, we get that BC is equal to negative 262.44 pounds.